Okay, now let's talk about cone, which is a pyramid with a base of a circle. So once again, we are going to go up to our shape, grab the oval tool, and begin to draw our oval. Now we talked about how on a pyramid, all the faces come to a singular point, and that point needs to be directly above the center of the circle, otherwise it will be considered oblique. So the first step that we're going to do is zoom in and find the center of the circle so that the height can be directly above it. And by directly above it, what I mean is perpendicular. The height has got to be perpendicular to that base. Sorry. Sorry again if the clicking noise is very, very loud. Okay, so there's our radius. Yeah? And we want our height to be perpendicular to that. So actually, I'm just going to take this little guy and move him up. So he's right at the end there. And then I can drag my height as high or as low as I need it to. See, we want to make sure we don't waver to the side. We want to stay nice and perpendicular to the radius. Right there it is. Okay, now I'm going to stay zoomed in as I connect these, because if I use the guidelines, the guide circles, if you will, remember these guide circles here and here and here, if I use these guide circles and connect it to here, it's going to look kind of awkward. Here's what I mean by that. See that? See how it cuts through? That looks really awkward. A perspective wouldn't really do that to us. So instead, what I'm going to do is I'm actually going to connect it to not one of those points. I'm actually going to connect it to right where it blends in, right there. So it makes a nice smooth transition into the circular base. Now I'm going to have to do the same thing on the other side. Right there would be good. And I am a little bit off with connecting. It does kind of bother me a bit, so what I'm going to do is I'm going to zoom in. I'm actually going to shorten the length of my segment there a bit. Now, here we go. Keep in mind that these lines you're drawing on here are actually real skinny rectangles. So pixelation says that it's not going to be perfect here, and that's perfectly okay. I'm not going to be zooming in super duper fine to make sure that it comes to a point. But those things can be very noticeable when you zoom out. In fact, I can notice a little bit here right now. That's all right. All right, so we've got our cone. And again, the two dimensions of a cone are the radius and the height, just like a cylinder. So we'll go ahead and label those right now. Oh, look, there's all our fun stuff from the previous one. Go ahead and get rid of that. And we'll come in here, and I just noticed that the circle base is a little bit gray, but you've seen how to change that before, so I won't go into that. But there's our radius there, and there's our height there, right? Again, pardon the terrible handwriting. And we can make these up just as normal. Let's say that this is 5 centimeters, and this might be 7 centimeters, because it looks just barely above that 5, but maybe not barely enough to be 6. There's one other dimension of a cone, and unfortunately you do not get to make up this number yourself, and that's called the slant. That slant would be that diagonal that comes from the peak of the cone all the way down to meeting to the base. That's this guy right there. Sorry, that guy right there. A slant. And we don't know what his dimension is, we actually have to calculate that ourselves based on the radius and the height that we've been given. If you create your own slant without calculating it, it is very, very likely that you will not have created a correct slant to fit that radius and height. Chances are very slim, and therefore all your calculations for the surface area will be incorrect. Surface area is the only part that relies on the slant. The volume does not. I'll get more into the slant in just a second. Let's start with the volume once again. And like a cylinder, the volume is pi times r squared times h, but obviously it's not a full cylinder. What's interesting is that you can take 3 cones, the exact same size, same radius and same height. You could smush them together and make one singular cylinder of that same radius and height. So literally the volume is 1/3 times pi times r squared times h. Imagine that's a square. Then we've got our surface area, which is going to involve that slant that we talked about previously. The first thing we want to do is calculate that slant. To do that, we're going to be using the Pythagorean theorem. Okay, so if you look on the diagram that I constructed, you'll notice there's a right triangle there, constructed by the radius and the height, and the slant on the right-hand side. Which, as long as we're not oblique, the two slants should be the same. We're going to use the Pythagorean theorem to figure out what that slant is. Now, the Pythagorean theorem states that the sum of the squares of the two legs of the right triangle is equal to the hypotenuse squared. In this case, the radius and the height are the two legs. So the radius squared plus the height squared will equal the hypotenuse, which is the slant squared. So you will utilize the Pythagorean theorem to calculate the slant. Now that you will be rounding to the nearest hundredth, just as much as you have everything else. And yes, that means if you have a rounded slant and go on to use that in the surface area, that means your surface area will have more error in it, but that is okay. Excuse me. Unless you happen to create, by chance, a perfect Pythagorean triple, then your slant would come out as an integer. But the chances of that happening again are fairly slim, very possible, but also slim. You want to be careful because if you miscalculate the wrong slant, or even if you round it incorrectly, that automatically makes your surface area incorrect. So we got to be very careful there. Our equation for the surface area is going to be pi times the radius times the quantity of the radius plus that slant. So a little smaller than the surface area of a cylinder equation. We still have parentheses and have to start there with the addition. And then once we get past that, it's all multiply from there, including pi, rounded to the nearest hundredth, putting correct labels on our answers.